interesting aspects because they have so many services that we can't really compare all of them in the given short duration. But let's talk about what makes them good, what makes them bad, and how mature they are in general. So that will be the primary agenda and primary focus, and then we'll take two use cases, primarily the futuristic use cases like serverless and Kubernetes sorts, and see how these clouds compare against each other.
1 second.
Mm-hmm.
Is it a recordable? The session is?
The session is getting recorded, yes.
So shall I get the link after this completion of this meeting?
That I will confirm. Yeah. When was this?
This is Uday from Schneider Electric from Bangalore.
Oh, okay, sure. Let me check with that, and we'll let you know there. Thank you.
Yeah, fine. It's okay. No problem.
I think we can start, guys. All right, Chandra, can we start?
Yes, Shivasa, you please start.
All right, thank you, guys. All right, good morning, everyone. My name is Shiva. I have around 15 plus years of experience. Have worked across various companies. Was part of Apigee, which was acquired by Google. Was part of Thomson Reuters, and was part of many different companies across the globe. Primarily work on cloud computing, digital transformation, APIs, and microservices. That's my primary specialization. That said, we have been hearing a lot about cloud computing. I'm sure most of you would be hearing about cloud computing all the way from 2005. And there have been a lot of things, right? So if you see AWS came in 2006, which was the first public cloud offering, which came in 2006. Shortly, Google announced in 2008 that they were also ready for platform as a service kind of an approach. So Google announced their services. Last but not the least, Azure joined their premium league by 2010. And if you now see the number one being AWS, number two being Azure, number three being Google Cloud Platform. These are the three top platforms according to the market shares. But definitely there are some niche players as well. For example, IBM Cloud, Oracle Cloud. We have small players like Linode, DigitalOcean. There are many players in this particular area. It depends on what the organizations are really looking for whenever we talk about clouds. So what we are going to do today is we'll actually start from the business point, and then if we need, we can even talk a little bit on the technical side. So let's see what the standard businesses feel about the various clouds. So whenever we talk about businesses, for the most part, we kind of go by the standards. So as you can see, this is the Gartner report, which is always one of the reference standpoints or reference guides for uh, the businesses, right? So as per the Gartner report, this is the latest Gartner report, July 2019. You see that Amazon Web Services is the topmost leader with a distant second of Microsoft somewhere here. So if you see this magic quadrant of Gartner report, right, it is actually it's a very detailed comparison report, what you kind of get to see. So luckily, Amazon has been on the top from the day one, almost 2006 onwards till now. I think they have the highest number of services, irrespective of whichever aspect you look for, and there are too many options for the same thing to be done as well in many cases. So Amazon is the most matured cloud out there, followed by Microsoft. Microsoft has an advantage because Microsoft always has been an enterprise-oriented company. So they always had tie-ups with large enterprises. So it was an easy go for them compared to that of Google, which is on the other hand, which was always a customer-centric company, or a social-centric company. So Google is a distant third. As you can see, it is just above the magic quadrant in the leaders. And most of the other ones, if you really see, some of the niche players are like Oracle, IBM, Alibaba Cloud. I think Alibaba Cloud is picking up quite rapidly. Oracle and IBM. So IBM, I think next year we should probably see them somewhere close to Google in certain areas. That's what is my guess because of the recent acquisitions by IBM. Now that Red Hat is acquired by IBM. So there are things which are changing in this particular space. This is an amazing space. It is not, and it is a space where there's a lot of competition. Each of these vendors have their own way of dealing with their offerings and things like that. So we'll actually understand what they offer, and we will see how they really compete with each other in general. So for the sake of this discussion, I'm just comparing these three guys, okay, who are in the leaders, because as enterprises we generally go with leaders instead of going with niche players, unless there is a specific requirement that you are logged into Oracle for some reason, and hence you had to go to Oracle Cloud and so on. Other than those reasons, I think sorry. Other than those reasons, I think for the most part we actually go with the traditional three leaders which we tend to see in this Gartner's report. Yeah. So that's let's actually move to the next slide. So Gartner actually kind of compares them based on something. There are three criteria. They're like, what are the required offerings, what they have, what are the preferred offerings, what are the optional offerings, because there are too many services which are offered by these cloud vendors. It could be, whenever we talk about cloud, a cloud is not only about running your servers in the internet. It is also about the compliances, the security standards, the measures what they take, the backups what they provide, the storage services, the network services, the hybrid models. There are a lot of different things which come into picture. At this point, if you see, Amazon was always on the top. Looks like Microsoft is picking up very rapidly. This is almost the second last report which I have, where almost all the required features, Amazon and Microsoft are literally competing head on, whereas the other ones are still a little far off. For example, there was no storage service in Google till the recent times, or storage archival service, right? So there are certain areas where the other clouds are definitely, lacking, but there are certain areas which Gartner, according to them, feels most of the enterprises would need these services. Those are the services which are generally marked as required. Most of the services may be something like optional, for example, AI, ML, character recognition, speech to text. All of these are not really a must have, but they're good to have sorts. So some of them are optional, some of them are in preferred bucket, and so on. So if you see, Amazon definitely has more in that particular criteria, 77% of optional and preferred offerings what they have. And we'll talk more about some of their offerings. There are a lot of offerings from Amazon. So I have been seeing Amazon from very early days. So I should say I have seen when they even had 120 services, and now they have around 1,000 plus services. So there's a huge growth in the last 10 years. So last 10, 12 years at this point, right? So we will talk more about some of these services which are offered by each of these cloud provider. And Google is definitely playing a catch-up game. They're somewhere there. In many cases, they're just catching up with the Amazon and Microsoft in different areas. You may be using Microsoft Cloud in many cases without your knowledge. For example, like a SaaS, like a Office 365. If you're using that, you're indirectly using Microsoft Azure. Yeah. So these we will talk more about it. And Amazon was a surprising, outcome because if you know Amazon was a retail giant. In fact, there have been episodes where Google had commented about Amazon regarding uh, being in retail and being an IT company and so on. But if you see, Amazon has come out a very great deal in this particular respect. Yeah. Let's move on to Oracle. Oracle is something fairly new. We'll talk about Oracle and IBM in the further slides, but for the most part of our discussion, let's restrict ourselves to Azure, Amazon, and GCP. That will help us to kind of compare them a little more efficiently. So the Oracle Cloud is still a long way to go. IBM Cloud is also having a very long way to go, even though they were a little ahead in the AI terms. So AWS, I'm sure all of you might have heard of Amazon Web Services by now because of the kind of services what they have for, or most of the initial cloud migrations were on AWS. In fact, many companies use AWS as their primary backbone, including Netflix, Cura, Airbnb, and many more. Actually, they use AWS as their backbone. So it is the most mature client because it was the most mature cloud. In fact, it is there from 2006. It has the largest number of capabilities when it comes to providing optional services. So there are literally too many optional services what AWS has to provide compared to that of the other vendors in this particular space. The biggest weakness is actually related to cost. We'll talk more about it. We see Amazon Web Services, when they came, they've actually have been reducing the cost on a frequent basis, depending on the competition or depending on the maturity or depending on some certain benefits. They have been trying to reduce their costs. One of the biggest challenges when it comes to Amazon is to figure out what would be your average cost of operations. That would be the biggest challenge because there are many parameters. So you're charged not only for the server, you're even charged for the traffic. Maybe that is one of the cases where, let's assume if someone started an attack on your server or something like that, unless you prove that it is a attack, there is no way to kind of get rid of your network traffic and things like that. So we will talk about some of the scenarios where it really matters. But overall, it is, in simple terms, the biggest challenge with Amazon. Even though they have too many services, it is little difficult to understand the overall effective costs considering the services which you are trying to buy or use. And most of the services at this point are actually per second charged. That is one thing good. Initially it used to be per minute or per hour sorts. It moved to per second. So we have been tracking Amazon from quite some time. When they announced the per second charging, it's quite nice. So if you want to do some sort of a load testing scenario or some sort of a scenario which just needs some random traffic, the server is just going to run for 2 hours or 3 hours, you'll be exactly charged for the same instead of being charged for the whole day. That's a huge cost reduction for the companies. So AWS is the most matured one, Amazon Web Services. Next, followed by Azure Cloud. It started in 2010 sorts, but it definitely became bigger because of the existing brand value. Also, Microsoft, announcing Microsoft Linux was a big move because most of our cloud services or most of our server workloads generally work on or generally are deployed on Linux. So Microsoft themselves announced a Linux, and they kept being, or the cloud is quite open in order to kind of bring in your own open source operating systems, let it be CentOS or any other operating systems for that matter. That added a lot of value for them. So they are definitely competing in this space. Sometimes the maturity is little less compared to that of Amazon. Sometimes the options what they have are more than what Amazon has. So it all varies. It's not really like a apple to apple comparison in many cases. None of the clouds are almost an apple to apple comparison. Reason being, all of them are different. So if you see Amazon comes from retail and books and retail and the commerce background, whereas our Microsoft comes from enterprise background. So they're enterprise ready cloud in certain areas. And if you see Google, their focus area is slightly different for them, so the social areas are the primary areas where they are strong at. So all of them have their own strengths and weaknesses, and hence each cloud also kind of exhibits somewhat similar behaviors. Yeah. So Azure is tightly integrated with a lot of their tooling support what Microsoft provides. That is one of the good things about this enterprise ready, or enterprise heavy focus of these companies. What they kind of work a lot on their tooling aspect compared to that of the other ones. And so for the most part, Microsoft kind of gives you a huge discounts for the existing customers when they kind of migrate to their own cloud and so on. Next comes Google Cloud. Google Cloud has been there from 2008. Google kind of started with something as Google App Engine, where you can actually deploy your Python applications and so on. So they were actually platform as a service when they started, more than as an infrastructure as a service. But at a later point, they realized that the game was quickly changing. People were interested in running their own applications and so on. At this point, it's a distant third in many cases. But in many cases, you would see that the Google is more cost effective, or I should say cost effective in many regards, compared to that of Amazon and Azure in certain criteria. So we will see two use cases in both of which actually you will find that because of the kind of nominal costing which Google does, you may end up being benefited in Google Cloud. So there is no harm in sometimes picking a distant third as well. So you may want to figure out how to kind of consider these cloud options. One of the biggest challenges with all companies deal with is the vendor lock-in, or a cloud lock-in as we call it. So at this point, we have kind of seen organizations which run their instance across multiple clouds just to ensure that you're not totally locked into a single vendor and so on. So there seems to be different ways of doing this. So we'll see how we are able to kind of understand uh, the aspects, the positive aspects, as well as some of the negative aspects when it comes to uh, picking a particular cloud. All right. Let's move on. Let's actually compare some of the basic strengths and weaknesses when it comes to these clouds. You might have seen some of these strengths and some of these weaknesses. One of the biggest strength is with AWS is it is a dominant leader in the cloud market. There are very matured offerings in many scenarios. You have a large support ecosystem. There is a lot of there's a lot of workforce which is available who are actually certified and who can help you achieve your business goal with ease. And it's not really a very difficult cloud to kind of catch up with as well, even though it is a little complex and different or difficult to use in the initial days. You could kind of manage your large teams, or you could kind of enable your teams to get into AWS fairly quickly because of the kind of knowledge base what is available. There are a lot of effective trainings because it is there from 2006. So there's definitely an aspect of maturity which adds certain edge to AWS compared to the other clouds. There's definitely a global reach. There are a lot of data centers and lot of availability zones across the globe. I think it has the highest, followed by Azure. So that is a dominant position what AWS enjoys. There are reasons for it. For example, AWS itself is a global e-commerce giant, and also they have offerings like Prime Video and others, which make them ensure that their own business runs globally. So definitely they ensure that they have vast coverage as much as possible. One of the biggest weakness when it comes to AWS is cost management. So the only complexity is there are a lot of moving parts that you will not be able to exactly judge that your cloud bill is going to be X amount. Okay, and in fact, cloud optimization is a biggest. It's a big topic in itself, and it has many different aspects. Let it be the number of operating or number of VMs which are running, or the amount of traffic which is going on, or how many parked VMs you have. You can have different cases. So that's a little complex scenario, but overall, definitely AWS being in the dominant position still offers you the best in the class in many scenarios. Followed by Azure. It is the second largest provider, has out-of-box tooling support for most of the Microsoft tools, like even Skype and Office 365. All of them run on Azure Cloud at this point. They have a wide range of feature offerings as well, similar to that of AWS. Almost in every space they have good offerings. So that's one good thing. They also have a hybrid cloud support. All of them have a hybrid cloud support at this point, almost. So there is no specific difference. They're also now kind of supporting open source a great deal, at least from last 5 years or 6 years, I should say. So which really has helped them grow quickly compared to that of Amazon, which was always there as a number one. One of the biggest challenges is because Microsoft kind of has been rapidly ramping up. Sometimes the documentation may not be as complete or as efficient, or as it is quickly changing, right? So there are rapid changes. Hence, sometimes you have some issues with documentations, some issues with some of the management tools. Sometimes there have been scenarios where it takes a little longer to kind of create instance and get you that instance in place. Whereas if you see in Amazon or Google, you will just get it in seconds and minutes in many scenarios. So those are the kind of challenges what at least I have seen in Azure. There are a lot more than this, but I'm just highlighting some of the basic ones. Each of them have their own strengths. For example, when it comes to APIs, we'll talk more about it, or Lambda functions as a service. At that point, I'll highlight some of the differences, which are the new things in the market. So Google, as you see, Google always has been designed for cloud native businesses. They are always have been cloud native in offering, because their Gmail itself was a cloud offering to start with, right? Even the Google, so Gmail, and there were many other services which they offered, which were generally customer centric more than being enterprise centric. So that is the best thing to deal with when it comes to Google. They are definitely, kind of, if you ask about the commitment towards open source, there are a lot of projects and a lot of languages which Google has open sourced compared to most of the other companies in certain areas. Especially if you have to compare Microsoft, AWS, and Google, definitely Google has done more on the open source grounds compared to that of Amazon or Google put together. Amazon or Microsoft put together. They definitely have a lot of DevOps expertise. They have been, they're actually gaining popularity from 2015, I should say, because of technologies like Kubernetes, where they have been using something similar in their own infrastructure from very long. So that's how they actually came up with Kubernetes, which is an orchestration or a container orchestration service. We'll talk about comparing the costs and things on this, as well as the maturity in some of these areas. The one of the biggest things is they started as a platform as a service. They started as a Google App Engine, where you can just throw your application and get your application up and ready. But they entered into IaaS market a little later. We'll talk about what is IaaS, what is PaaS, and so on. But I will not spend too much time there. I just want to highlight that there are two new things which have got added into this AaaS, which is as a service kind of a scenario. So each cloud vendor also have those supports at this point, right? Historically, it is not enterprise focused. These are some of the actual weaknesses when it comes to Google compared to that of the other two which are there in this area. So this is the slide which I wanted to talk about. This is a very generic slide. Don't really compare them. This is not really a comparison slide. I just wanted to quickly kind of go through some of the focus areas. So we always, if you had read any cloud computing book, I'm sure you would have seen these three, like infrastructure as a service, platform as a service, right? And then software as a service. These are three things which we always talk about. So what is the reason? Why do we have something like container platform as a service or a function platform as a service? These are the two new entries, right? CASs and FAS are the two new entries which you're seeing probably. There are reasons why this came into existence. So if you see, infrastructure as a service was good, where you run your servers or the servers which you always have been running in your own data centers remotely. That would have been the most common scenario for most of the companies. Lift and shift. You just lift your existing infrastructure, existing applications, find an equivalent provider, and just drop it there. That's a simple infrastructure as a service. In many cases, you could actually buy your network, your compute power, your storage capacity. Those are the important aspects when it comes to infrastructure as a service. Whereas we have things like platform as a service, where you had something like Elastic Beanstalk and PCF and many other, uh, platforms as a service, which are actually built on top of infrastructure as a service. Here, all you need to do is bring in your application and they will take care of running it for you. They kind of provide you some amazing features like auto scaling, replications, and lot of features at this particular place, especially on the platform as a service, where you're not really worried about anything else, about how many servers it's using, what's the computing power using, or what is the network setup which we need, and all that. You're just bringing in your application and it starts to run in many cases. So that's your application platform as a service. Last but not the least, we have software as a service. This is the highest maturity when it comes to, you're not worried about where it is running, where is it hosted, or anything for that matter. You just bought the software and you're using it, like Office 365 or maybe Gmail. Gmail is a very standardized SaaS platform, because hardly you can change anything other than logo and some themes and some basic configuration. On Gmail, you can't really change anything. You can just gain more storage space. That's the only thing you can buy if you ever want to buy. So what happened was, people were moving their applications to platform as a service, or they used to build their old stuff and manage their own applications on infrastructure as service. So those are the most common scenarios. But once you move to a platform as a service, it was not easy for you to move back to your own data centers, or you used to feel that you are logged into that particular vendor. That is the most common feeling which many companies had. So because of that, people kind of people started working on containers. I'm sure most of you would have heard of Dockers. Dockers are not the only containers, by the way. There are many other container runtime engines, but Docker is the most popular one, uh, because of certain offerings what they made. For example, they have something called hub.docker.com, which is a container registry, and kind of many people at this point offer their softwares as a Docker container, which makes it easy for people to run. So container platform services are the new ones. What they are actually able to do is, you create your applications, or you create your application based on containers, and now you have an ability to move your containers around different vendors, different customers, different clouds. It doesn't really matter where your application is running. If you have a powerful enough server, probably it can run on your laptop as well. So that is the level of granularity we are getting into, especially with the new trends like microservices. These are gaining a lot of popularity. So that's one of the reasons why container platforms as service have become very popular. As you can see, all of them offer the same or similar features. If you see, Google has Google Kubernetes Engine. Uh, Amazon has ECS, which is Elastic Container Service. Azure has Azure Container Service, and so on. All of them are capable of running a managed Kubernetes cluster or some sort of container platforms, in simple terms. So what they are kind of promising is, okay, we will not lock you down here, but instead you can actually bring your own containers and you run them here, and you will be able to move the things around the different vendors for the most part, because containers are really portable for the most part. That is the advantage what you get here. uh, there is already a different segment of services which we are looking at. These are also known as nano services, or serverless technology. So if you have heard of something like AWS Lambda functions, or Google Functions, or Azure Functions, or Google Cloud Functions as they call it. These are some of the serverless functionalities. These are some of the serverless functionalities which makes your applications to listen for certain events, and only those are based on those events. They will just do or they just perform the task which they need to perform. So it's a nice way to design microservices this way, or it's a nice way to design applications which are event driven. But it takes a lot of effort and a lot of maturity for the organizations to start building those kind of applications. What is the problem here? Why are they in middle of PaaS and SaaS? Is because once you're building, let's assume you build something on Lambda functions, you will not be able to move those Lambda functions to any of the other uh, other offerings, because Lambda functions are very, specific to AWS. They kind of take care of initializing, they kind of take care of how they are supposed to execute and so on. So they are higher than that of PaaS, but they kind of give you a benefit of not to worry about any of the server or any of the infrastructural aspects which you need to usually worry about when you are doing either here or kind of here, where you kind of pre-reserve your computing space. Here you just put your task or put your functionality as a function, and it will automatically execute based on the events which are configured to be done. Yeah. So this is a very interesting space, and there's a lot happening in this particular space. So Kubernetes nowadays also has support for uh, there's something known as kubeless and knative. There are two ways in which you can actually run function as a service even on top of Kubernetes. So it's a very interesting space. So these are some of the spaces which I just wanted to highlight for SaaS. I'm sure you can actually, for example, Salesforce is a great example for SaaS, right? Salesforce has been kind of an SaaS offering from a very long time, and in fact, it is the one of the best out there. SAP has SAP HANA, which is also an SaaS offering. It also kind of gives you all the capabilities of SaaS platform over the cloud. So I just wanted to kind of conclude this quickly, saying there are some new things which are happening here, like SaaS and FAST. You may want to kind of see SaaS and FAST, and you may want to kind of keep tracking this, because this is the area where we are seeing a constant innovation happening. All right, so let's actually compare some of the basic, offerings what they have, especially for the compute services. If you see, AWS has a lot of different options for the compute services. It is very difficult for us to kind of pick whether we want to kind of do this way or to do that way. For example, EC2 is like you running your own VMs and so on. Each of these services, right? If you see, even though they are container platforms, we have actually put the Elastic Container Service, Elastic Container Service for Kubernetes, because they had their own proprietary version of something similar, and Elastic Container Registry, where you actually can kind of register and discover your own containers and so on. These are some of the new offerings which AWS added. Other than this, they also have a typical lightweight VMs like Lightsail, batch processing, Elastic Beanstalk, and so on. These are all some of the offerings for the compute. Azure kept it very simple. They call them simple virtual machines. So you're actually free to just pick what virtual machines, and they call it virtual machine scale sets and Kubernetes service. So all of these are computing power related services, what they have to offer. I don't know if you've heard of Service Fabric. Service Fabric is actually a very interesting offering from Microsoft. If you guys are a .NET center, probably you may want to check what they have to offer, because Service Fabric is a way to kind of even run stateful microservices. So they kind of give you a lot of but again, as I said, right, so once you pick a particular technology, you are kind of little logged along with the offerings which are made by Microsoft. In this particular case, they kind of give you something known as actors and things like that, which are amazing. So you may want to kind of explore Service Fabric if you are a Microsoft shop. If not, you're better off taking something like Kubernetes. Yeah. Similarly, Google has Google Compute Engine, Kubernetes, Google Functions. These are nothing but cloud functions, which are actually cloud functions. The App Engine and Knative are some of the features which Google has an offering to make. They also offer graphical processing units. As of now, even Amazon offers graphical processing units. That is one of the areas where we are seeing, people who are actually into graphical processing are much into the things in this area. All right. On the storage, so Google and Amazon, actually, I should say Amazon and Azure have almost equal capabilities in many cases, or even more. Actually, Azure is more specific towards enterprise. They actually have some of the backup, site recovery options, and so on. Whereas AWS just has a simple Glacier where you can actually dump a lot of data. So each of these offerings, in fact, I don't mind sharing the slide deck as well. So probably we will send it across so that you can actually get a view of what are these offerings. Actually, if you go to each and every one of these, there are too many options in each of those. Okay, I don't know how many of you have heard of Snowball Mobile or Snow Mobile. There are two things. One is Snowball Edge and Snowball Mobile. One of them is actually a truck okay, in which you can actually upload your terabytes of data and send it to a cloud center. So they have some very interesting offers. In fact, that's a big truck, which is a 40 feet long truck, in which you can actually load all your data and send it across. Because if you have terabytes of data in your company, maybe that is your own best bet in many scenarios. So AWS has the most matured offering, because even transferring a terabyte over a internet, how much ever speed you have, is not reliable in many cases. Okay. So similarly, Azure has a lot of options for blob storage, queue storage, and so on. Google Cloud Platform in itself has, again, multiple options. Some of the interesting ones are like the Google Cloud's Big Table, which is actually a nice offering from Google. So you may want to kind of check those. Recently, they actually started archival support. One of it is called Cold Line, one is called Nearline. Because if you actually put some data into Glacier, even though the cost of the data storage is very minimal, the cost of extraction and the time it takes to extract that information is higher. Okay, that's why actually Google came up with two options, one called a cloud line, another one called a nearline. Sorry, cold line, and the other one called a nearline. Nearline, if you use nearline, probably you'll get the data faster compared to that of the cold line, where it is actually kind of just secured and thrown somewhere into the data center, into the storage. So there are a lot of offerings in this area, guys. You need to kind of compare and focus on what is your expectation, and then only you'll be able to decide what storage services are appropriate. Each of them also have the artificial intelligence and machine learning services. There are a lot of these services again. So especially Amazon has too many of these, because they actually have both the machine learning side of it, as well as OCR, Alexa support, for example, Lex, which can kind of do speech to text, text to speech support is also there for that. For IoT, also they're fairly matured. They also have something known as device forms, which are not actually mentioned in this, but you can actually, if you have to test your mobile apps, you can actually take AWS device form, and you would be able to test your application across multiple different types of mobiles and see the results and so on. It's a nice offering, because for any mobile app developers, we know that testing is one of the critical aspects when it comes to large set of devices which are running out there. As I said, serverless functions, they have lambdas and serverless application registry. This was newly offered. I think this came only a year and a half ago, where they allow the lambda functions to search for each other or discover each other and so on. So these are some of the areas of things. And SageMaker, for that matter, I'm sure you might have heard of it if you're into the machine learning space of things. So these are some of the offerings from AWS. To compare them, I should say, if you're trying to do something like speech to text and things like that, you would get more support, or translation support on GCP is little stronger compared to that of the AWS Translate and things like that. So it is not apple to apple comparison. As I said, see, these guys already had some of the capabilities. These guys have built those capabilities. So both of them have their own goods and bads. There is Azure also is definitely picking up on this. Azure has support for IoT. Azure also has support for blockchains, for that matter, which are not mentioned here. But Azure has out of the box support for blockchains. Even AWS has at this point. I don't think Google has, but AWS and Azure, both of them have blockchain support at this point. So there are a lot of this is a very vast space. So depending on your area of expertise and your area of interest, you may want to kind of compare them by basis. For example, if you have to compare the lambda functions with serverless capabilities, these are the three things which you need to be comparing against each other. Definitely AWS is more matured in this space compared to Azure or GCP put together. All right. So there is actually a good website. It's called comparecloud.in. I'm not sure if you have actually seen it. You can actually go to this particular website. I will not spend time because I just gave you a lot of options there. Here you would actually see a clear comparison of each of the service offerings which they have to make, and how these service offerings would really help and so on. So it's a very nice website. It's called comparecloud.in. You may want to kind of consider looking at this, because that's one area where you want to kind of, you would be able to identify which specific area you're looking for, and you will be able to compare them against each other and take your decisions based on certain aspects. I'm sure as an organization you would already have a set of checklists which you want to compare against in many cases. Okay, so comparecloud.in is actually a nice website, which actually is an Indian website, surprisingly. All right, so let's just talk about. I will just take two use cases because I don't want to kind of compare some of the traditional VM scenarios. VM scenarios, it depends on whether you want to be charged or whether you want your VM's downtime to be considered to be charged, or whether the network is going to be heavy during the weekends, weekdays, and so on and so forth. So there are a lot of different aspects which will come into picture in those scenarios. Just to keep it simple, I will just take some of these newer technologies like Lambda functions, Google Clouds, and Azure functions. So here, if you see this, they generally charge you for 100 milliseconds. So that's exactly how they actually charge you for milliseconds. So the developers actually just need to worry about their code and events. That's all they really need to worry about. And if you see, let's assume our function needs around 512 MB and it executes 3 million times in 1 month. Let's see how much would be the cost. And every time it ran only for 1 second. Let's assume it's a very optimized function, which 1 second is actually a small time when it comes to running a function in some scenarios. Yeah. So if you see the AWS Lambda pricing, it's a fairly detailed pricing. What you will have is you'll actually have a you will have, so even we are considering some free tier to be there, so the free tier bill plus the actual traffic bill, this is your compute charges, which is nothing but your CPU utilization and things like that. If you put that together along with some of your network traffic charges, overall it kind of comes to somewhere around $18.74 per month, which is a fairly, for 3 million requests, that's a okay amount to price, because here you need not worry about what infrastructure you are actually uh, dependent on. You are not going to pre-provision any server. You're not going to pre-provision anything almost. This is just a function which is thrown into AWS and it starts to run. That is why this comparison is the easiest one to do compared to that of any of the other complex scenarios, like I want 10 VMs running together or something like that, because here you're not worried about the VM at all. All right, so here is an example of how this would look like. So this is around $18. As you can see, these are request charges and this is the compute charges. Put together it comes to 18.74. The same thing when you do it on Azure function, it's actually much simpler computation, because there are request charges somewhat similar is what you would end up being, and the compute price comes around $18, which is again somewhat similar. So both of them uh, are kind of getting to a same point. Whereas if you run the same function in Google Cloud, the interesting thing with Google Cloud is your compute charges are actually much lower, because it actually offers a lot of free tier provisions and things like that. If you don't, even if you ignore the free tier provisions as well, it is actually much cheaper compared to the rough most of the other clouds. Okay, so this network traffic charges are kind of similar for almost all the clouds. And if you see here, it comes to only around $4 or $5 a month, at the most 3.15 in this scenario. Okay, so when it is coming to functions, definitely Google is one of the areas. And also Google VM charges are actually relatively lower compared to that of AWS and Azure. I'm sure that these cannot be taken as a baseline prices, because every 6 months there will be change in the costing structures in each of these cloud vendors. So it is actually a very complex thing to kind of compare apple to apple in many of these scenarios. Okay, today these may be the numbers, just tomorrow if they may announce a discount and the numbers would vary drastically. All right, so what overall it says is kind of Google Cloud Functions is definitely cheaper. It actually kind of helps you reduce your cloud bill when it comes to cloud functions. But are we ready for cloud functions is a question which we need to ask ourselves. And most of our traditional applications, bringing them into clouds is a big task in itself. Okay, so it's an evolution more than a journey. It's really a lot of expertise goes into that area. That said, let's actually take a scenario where we are looking at, thinking of containers. I'm sure most of the companies are already entered this area or this era of containers in many cases, where you have large set of containers which are, orchestrated to make a application. So if you have a container-based application at this point, and if you really want to run it in a production cluster, take a look at this. We have actually a multi-node Kubernetes cluster with 5 master nodes and 15 worker nodes, so that it gives you the maximum resilience what it can give you. Each node is around 4 vCPU and 16 GB RAM, which is okay for a production server or production cluster for that matter. And for Amazon Web Services, this bill adds to somewhere around $2,800 per month because of the kind of cost, because of the it actually kind of maps to M4 machines or M4X large machines for that matter, which costs you around $0.2 per hour. And for a cluster like that, including the complete runtime, this kind of comes around $2,800. And on the Google Cloud, on the other hand, it comes around $1,600. They actually have somewhat similar. There are certain discounts which they offer because of the pre-provisioning costs. Even Amazon has pre-provisioning costs and things like that. So if you ignore the cost, also somewhere around $1,800 or $2,000 is where you kind of get to. See this 2052. If you ignore the costs because you're running for the entire month. So if you're actually running towards the entire month, you will actually get a 30% discount as of now. That's what Google Cloud Platform actually has to offer. Otherwise, even if you take, otherwise also it is around $2,052, which is lesser than Google, right? So, sorry, which is lesser than Amazon in this particular scenario. The same structure, if you run it on Azure, Azure kind of goes to somewhat similar to that of Amazon prices. You kind of get around $2,800 again. So definitely, even without discount scenario or even without discount, whatever cost you are going to encounter when it comes to running containers and functions, Google is your best, platform as of today, unless there is a price reduction, which is going to happen on Amazon and Azure. But when it comes to enterprise maturity, for example, if you have a traditional application which needs like 6 machines or 7 machines on which we need to install different services and put them together. So even in those usual cases, I'm sure, Google, Amazon, as well as Azure will come to somewhat similar bills like how we saw in terms of uh, not exactly the same bills, but somewhere there, every dollar you save actually adds a lot of value, considering every dollar you save a day kind of adds up to $30 a month and so on. So there will be a lot of changes when you kind of look at it from a long running standpoint. So the reason why I've shown Kubernetes and cloud functions is that's the future what we are kind of heading towards in many scenarios. So just kind of telling you that in the current state, definitely Google is the front runner in those areas, but even though it is front runner only in those areas, in other areas, Amazon and Azure are still topping. So that's the basic part which I just wanted to put together. So as you can see, if you ignore 2000, the 30% discount also, Google platform has around around $2,000 per month compared to that of what you're going to get on Amazon and Microsoft Azure. So there's a basic cost comparison, and this may not be accurate as well because it depends on various other, criteria. So you may have to make some decisions on this, right? So that brings us to thank you. I will just open up for questions, so we can actually, I'm open to take any questions you have, and we can discuss. Any questions, guys?
Hello.
Hi.
Yeah, Shiva. So I'm Viral from British Telecom. So basically, my query is regarding, let's say you told all the comparison stuff and all, but if you see the traditional enterprise, structure, right?
Mm-hmm.
So most of the enterprise, systems are running on different OS, different application server. The basic code which is written, right, it's in multiple languages. Then you go to the databases, right? Most of them are Oracle, but now if you see, most applications are being migrated to NoSQL and all those stuff, right? So when it comes to migrating a whole enterprise, right, which is having, let's say, 1,000 systems, or maybe if you take a small enterprise, it will be having at least 50 to 100 systems. When I say 50 to 100 systems, they have 3-4 layer architecture, right? You have a separate OS support, you have separate application server support, and if it's a cart application, right, then they have interlocking, that if you are using a Oracle app, basically some let's say you're using a Cbill and you want to migrate to Salesforce, right? So you have your WebLogic application, or if you want to migrate that Cbill plus the WebLogic combination to the cloud. So WebLogic itself is a big elephant, right? You cannot migrate it to cloud. So you need right? So how this roadmap is being achieved, the complete migration of a single application. I'm not talking about the whole enterprise because it becomes again a tedious task. So in these type of cases, right, so any company provides some roadmap, where you rewrite the code, because it's not migrating. Basically, you need to rewrite the application to make it cloud native and then move it. So
That's
what
actually
is
a
the
great question, Viral. So I'll tell you what are the ways in which you can do. Okay, so there are actually different ways in which. So each organization journey in this particular space is different. So let me actually talk a little bit about the new trend which is there in the market. You might have heard of microservices and cloud native applications at this point, right? So everyone wants to be in the microservices because they want to. They are thinking that that's the silver bullet and it will help them kind of break the elephant into a set of mouses and make it work together. So that's the current model. So if you really see, to break down a monolith, it's not a very easy task, but that's your best bet when it comes to achieving your agility and other aspects. So microservices are in get great trend because of the very same reasons. Containers are the right fit or a right way to kind of run your microservices because they kind of get you all the other options. So that is the kind of trend what we are seeing in the current market. To break a monolith into a microservice architecture itself is a long process. Okay, it may involve refactoring, it may involve rewriting, it may involve re-platforming. Okay, so whatever I'm using with re or all different phases within the journey of a microservices or journey itself. So going from monolith to microservices itself is a journey which most companies at this point are struggling with. For example, Netflix was a monolith. Netflix moved towards microservices with the help of Spring Boot, Spring Cloud, and they actually achieved uh, maximum resilience even before the existence of a container or an orchestrator. At this point, the technologies again have changed. So did Netflix just stop there? No, Netflix continued to evolve. They started taking advantage of Docker's, Kubernetes. Now they actually use Docker's, Kubernetes, Spring Boot, Spring Cloud, all of them in a way. See, the thing is, innovation happened from two fronts, one on the development side, one on the DevOps side. Both of them are merging at this point. Okay, that's the area at which we are. So if you ask me how easy is it to migrate one application, lift and shift is your easiest option, but that is not what you're really looking for. In many cases, you want to kind of achieve the resilience which was missing in your traditional applications, and that's the reason you are really looking for moving towards the cloud, ensuring the resilience is there. If it's only about lift and shift, you don't really need to worry much. But when it comes to thinking of taking care of the scalability aspects and others, microservices is the only option which currently is there for you. And as I said, there are two options even in terms of microservices. You may want to go either event driven way approach, which will help you take care of some of the challenges which you may face, but definitely not an easy path. It's not something which you can do in days. Definitely not in days. It is either a months or a years for sure. That's what, depending on the complexity of your monolith. Because understanding. So let me just, because you asked me a question which is actually my favorite topic as well. So if you see this, there is something known as microservices.io. This is a website where you actually see all the various patterns. Here is an example of how to refactor your existing simple application. He just takes a simpler application. He shows you how do you move towards ensuring that your application is scalable and is split in the right way. How do you split your databases? How to achieve your resilience and things like that. I'm not sure if you've ever seen this website, but this is the place where you may want to kind of check how to make your monolithic applications as microservices in the first place. This would be a good starting point for you. Here is a simple example what he has given. I'm sure your applications are definitely much complex than the example what he has given. In many cases, knowing or having people who knows the as is of our application itself is a challenging task. Someone who understands the functionality overall itself is a challenging task. So journey is definitely complex.
Yeah, sure. So, extending this question basically. So let's say you told about the metering part, right? How the companies bill,
Correct.
right? So now, if someone is moving from a bare metal or basically your in-house data center to these type of cloud services, right?
Mm-hmm.
So first part is security. Maybe now all the things are encrypted, right? But now coming to the billing part of it. So how we see the trade-off between the cost and the benefits that we gain, right? So if I'm moving my complete data center, I'm saving good amount of cost, but what I'm going to be built for the existing applications that are there in that bare metal data center. So how we do this trade-off at organization level?
At an organization level, doing the trade-off is definitely one of the challenging things, because it's not a apple-to-apple migration unless it's a lift and shift. In many cases, one of the biggest challenges which we'll face is, okay, to run this server within our own data center, what is the cost? See, it is when we talk about costs also involve the manpower which was there for running the data center itself, which currently we don't have as a bigger deal, because these data centers are now running somewhere else, or running close to us. We don't need to worry about those operational costs. But the people who are operating that particular, or someone who operates on these cloud vendors or cloud providers, still need to be considered, right? So the cost when it comes to bare metal to VM migrations, or these migrations, they depend on the manpower, they depend on the infrastructure costs, and they also depend on network costs. See, previously, most of the data centers were free. We never need to worry about the network part of it, right? And we never have to, for example, I'll tell you a simple thing, right? Whenever you used to do API calls, we never used to, or web service calls, we never used to worry about the network traffic. We used to just put or give back the maximum response we could. But nowadays, we don't do that anymore. If you really see the modern ways of designing APIs, we keep it as minimal as possible. We keep it, something known as HETIOS, or hypermedia as engine of application state. We keep it only on retrieval, or only when the client needs it, right? It's a client-side state management, unlike the server-side state management. So the way we are building applications has to be relooked, especially if you want to optimize the cost, especially on the clouds, because these guys charge you for the network transfer of data, whereas our data centers wouldn't have charged. I've never heard of any data center charging for network traffic, at least, right? So
Yeah.
those are some of the just some of the considerations. There are definitely more than this. No denial at all. Yeah, if you have a specific use case, we can definitely talk about it. But yes, so you said you're BT, right? So we kind of do work with BT closely. So yeah.
Yeah, and one more question regarding making the things. Basically, let's say we go for a specific provider, and we go for basically enterprise cloud, right?
Mhm.
Now, sometimes we need a good amount of bandwidth. Basically, let's say we have to scale the application for specific festive seasons, or specific occasions, right? So in that case, if we need extra machines, which maybe I want to make my enterprise cloud, uh, it kind of you see the active passive configuration that we do, right? So I want a passive machine at some other data center, where if the load is very high, I can just transfer the load, or basically make it hybrid, right? So
Correct.
how these things work, basically I have an enterprise cloud, right? And then I just want to scale my application
Mhm.
at specific events where I can take a bit of risk and pass it on to some public cloud platform.
So there are, so in EC, for I'll just give an example of EC2 because it's one of the most matured one. Okay. So actually what happens is there is a provision for auto scaling. You see this is an old 2010 post, but actually you can even open the new one actually. So what it allows you to do, what it really allows you to do is you could say that in the worst case scenario, when there is a need for scaling, I want you to scale up to all my other servers. So you pre-provision and keep certain reserved compute capacity. Okay. Let's say 30% over on top of your number of servers which you have. Okay. And it will automatically take care of scaling across those instances. That's what these cloud providers provide you. Okay. So they automatically scale up across these instances and provide you a way to kind of run this application across the new computing power what you have kind of provision. So EC2 auto scaling is there, and the advantage of this is it is actually kind of advantage as well as a disadvantage, because you will be paying for these reserved instances. There are something known as reserved instances. So this will be actually costed. They will actually give a discount of almost 75% if you actually buy reserved instances, because there is no guarantee that you will ever use them. But if you use them, fine, you'll be charged for those particular instances. Otherwise, you will still be paying 25% of the cost and things like that. So there are a lot of interesting options here. As I was saying, the best thing what you need to do is just go to this place, okay, and this called aws.amazon.com. Go to compute. You would actually see a lot of options within the compute, as well as there are a couple of use cases for each of them. See this? There's a use case which you're talking about where based on the load, you are actually planning to auto scale things. Say this, there are certain benefits in this chaos, and they will actually give you a purchase options which will reduce your costs and so on. So you can actually pre-reserve some of these instances. They also have EC2 on demand where you didn't pre-provision, but suddenly there was a need for you to scale up and so on. Here you actually will end up pay as you go model. So each of them are charged differently. So this is like as on dynamic basis, you are actually suddenly provisioning a new instance and it will start to scale. That's the expectation what you have here. So these costs are a little higher than that of the reserved instances. I would recommend reserved instances if we really know that, yes, there is going to be X amount of increase in traffic during those seasons. Or I would recommend on demand if you really don't know what may happen. Only on demand, it has to scale up. So there are different options what you get to see just on the scaling part. So each cloud vendor has the similar options. You can actually see even the Amazon, even the Azure guys, they have a similar option for this. Okay.
Yeah, thanks you.
No problem. Any other questions, guys?
This is Uday from Bangalore.
Yeah, please go.
Just to have one small question. So, how this Microsoft Azure is going to be helping DevOps platform? So, either for deployment or giving build like that.
Yeah, that's a nice question. Actually, most of them have out of the box support for DevOps. They actually have something known as Azure DevOps. It's a complete offering. Okay, they actually have an end-to-end DevOps capability where you can see that these are all the various services. They have a repository, they have pipeline. Now that they even have GitHub, so there is they kind of have a full-fledged offering around the DevOps practice, right? So they kind of have the pipelines, they have the repositories. Just give me 1 second.
Okay.
Yeah. So all of these are the things which they actually give you out of the box. You really don't need to do anything at all when it comes to the DevOps part. And this is actually nice. Even Amazon has it. Amazon also has this thing. Okay, so if you go to solutions, actually go to products, it's easier. And if you go to developer tools, you actually see this code build, code commit, code deploy, code pipeline. All of these are somewhat similar to that of what you're actually seeing on the Azure side of things. Even Google has them, but Google is slightly different. If you are comparing, I would recommend you to compare for the enterprises. Amazon Azure are more matured at this point compared to that of Google in the current day. So they give you all of it. They're already there. You just need to kind of worry about committing your code, and they will actually pick up and start running your code. That's the level of optimization what they kind of give you. Right, so that is the DevOps part of it. You just you will actually get a complete view of what's happening in this particular area, and you will be able to take it from there. There are a lot of extensions as well which you can buy. Like if you want to do support for Sonar Cube for that matter, or some sort of a code quality checks or anything. See, it's all free. Most of these are actually popular. They are free. You can actually add those extensions, and they will automatically start working with your application immediately. See, Postman reports, Datadog for monitoring your data. Again, you will pay for Datadog as a service and so on. So there are a lot of offerings, even Slack integration and so on. So there's a lot of maturity in this area. Azure DevOps is actually considered one of the good ones just after Amazon, because Amazon was there even before Azure in many cases.
Okay.
Yeah. So this is the one which you may want to explore, because this is actually good. You may want to kind of try it. In fact, they actually offer you a $200 credit. Most of these clouds offer you a free trial where you may want to try things firsthand and then decide whether it is suiting your requirements or not. If it is not suiting, you probably may want to kind of consider moving on to a different cloud. That is the benefit of having multiple clouds and the maturity across these clouds. Yeah. So, for example, if you need Selenium, I think even they had a Selenium plugin. I'm not sure if it is there in this one, but yeah. So depending on what you are really looking for, they do have offerings. All right.
All right.
Any other questions?
No, Shiva.
All right.
Shiva, if you are recording this and if you can share the slides as well, it will be really great.
Sure. Sounds good.
Yeah.
All right. Thank you very much for your time, guys. It was nice
Thanks.
talking to you over a weekend. Have a nice weekend, guys. Bye.
Thanks a lot, Shiva.
Thank
Bye.
you.